Okay, so we talked about inverse functions today. So this is your introduction. We're going to start with graphing f of x equals 3x plus 2 using a table. So we can just pick some values, maybe like starting with -2. So we can go -2, -1, 0, 1, and 2. So now all we're going to do is I'm just going to take -2, and when you plug it into 3x plus 2, so that would be 3 times -2, and then plus 2. Okay, and that's going to equal -4. Okay, so here is going to be -4. And then you're just going to do the same thing. So -1, when I plug -1 into function f, I get -1. When you plug in 0, you get 2. Plug in 1 is 5, and 2 is 8. Okay, so we're going to graph. You see that I have this second document open. So this is just a piece of graph paper. So I'm going to plot my points. So -2, -4, -1, 1, 0, 2, 1, 5, and 2, 8. Okay, so there's my points. I'm going to get a line and then try to draw a line through my points. Okay, good. Now, number 2, we're going to do the same thing, except you'll notice for number 2, it says interchange the x and y coordinates of the ordered pairs found in step 1, plot the points, and draw the line that passes through them. So, okay, up here in step 1, we have the ordered pair -2, -4. Well, we're going to swap that. We're going to go -4, and then down here for your y value is going to be -2. And so do the same thing with all of the points. Now, when you swap -1, it stays the same. Okay. But then instead of the point 0, 2, this would be the point 2, 0, and then so on. So then this is 5, 1. And last one, 8, 2. Okay, so same thing, go over here to your graph. I'm going to plot those points now. So -4, -2, and then -1, -1. So they're going to intersect at -1, -1. There's 2, 0, 5, missed that one a little bit. There's 5, 1, and then 8, 2 is about right there. So again, you can draw a line. And, okay. Oh, I think I put the point in the wrong place there. Okay, so this one. All right, so there's my 2 lines. Okay, now we're going to go back over here to the left. And we're going to look at number 3. Write an equation of the line from step 2. Okay, so there's a couple of different ways we can accomplish this, but probably the one you're most familiar with or use the most often is y equals mx plus b. Okay, so m, remember that m is your slope. There's a couple of ways we can find slope. You can count rise over run, or you can do your difference of your y's divided by your difference of your x's. And then b is your y-intercept. Okay. All right. So if we look at my red line, we have points. So like this first point here at -4, -2, and then I can do rise and run. So I can pick any of these points on this line. I'm just picking this one here. So if I go up 1, and then if I run 3, I get to that next point. Okay, so then that's going to give me a slope of 1/3. So for this equation, I've got y equals 1/3 x and then plus b. So b, the y-intercept, is what we need to figure out next. And again, there's a couple ways to do this, but probably the easiest is you have a table full of points up above. So if we take one of those points, I'm going to take probably this point 2, 0, be a pretty good one to use. So I'm going to take 2, it's going to be plugged into the x, and then the y, I'm going to substitute a 0. So this becomes 0 equals 1/3, and then times 2, and then plus b. Okay, so this is 0 equals 2/3 plus b. Okay, and then if I move the 2/3 to the left side, to get b alone, b is going to be a -2/3. So I can now rewrite my equation, and this is going to be y equals 1/3 x minus 2/3. Okay, so that's the equation for my function. And I'm going to call this function g. So this could actually be rewritten as g of x equals 1/3 x minus 2/3. Okay, now if you were in class with us today, we did our graphs on a piece of paper so that we could fold our piece of paper like number 4 tells us to do. So I had everybody fold their piece of paper so that your two lines match up with one another. And what happens is you'll notice your fold line intersects where the two lines intersect. It also goes through the origin. And if you look a little more closely, it has a slope of 1. So I'm kind of trying to draw in a dotted line for you where that fold line would be, where that crease would be. Okay, and then we talked about the fact that this line, okay, where you fold your paper and the two graphs match up, that line is like a line of reflection. You talked about reflections in geometry. Okay, so if I reflect my purple line over that dotted line, it lands on my red line. Okay, so we also talked about how that fold line is going to be the equation y equals x. Okay, so that becomes a reflection line. Okay, so 5, f is the function, 3 times x then adds 2. So then we found this function g up here. So we could write a similar statement about function g. We could say g is the function that is 1/3 third times x and subtracts 2/3. Okay. All right. Okay, we've been working with composite functions a little bit, and that's what I want to show you here with 6. So this is kind of an important step. So we're going to do f of g of x. So really what this says is that g of x gets put inside of the function f. Okay, so when you write that, your function f, so f was 3x plus 2, and then function g is our 1/3 x minus 2/3. Okay, so when we distribute, can you all tell that I left my stylus at school? So this looks fabulous. So when you distribute, the 3, okay, so 3 times 1/3 x, that's going to go to x. And then 3 times the negative 2/3, that's going to become minus 2. And then you are adding 2. So when that simplifies, you just get x. Okay, now if you do the other direction, g of f of x, so this time f of x goes inside of function g. So function g was 1/3 times x and then minus 2/3. Okay, so g or f, so 3x plus 2 is what goes inside of that g of x. So again, we're going to distribute. So that 1/3 times 3x goes to x, plus 1/3 times 2 is 2/3, and then minus 2/3. Okay, so those cancel each other out, and you get x. Okay, that's an important concept. So when you have these graphs that reflect over that y equals x line, like our two do, those are called inverses. So this last step down here, okay, these are inverses of each other. What relationship is there between the compositions of f of x and g of x? Well, they both equal x. Okay, so what I want to kind of summarize for you is I want to look at both of these real quick. Okay, so these graphs are inverses of each other. Okay, and again, there's 3 ways that you can tell whether or not you have inverses. Okay, so the 3 ways are what we started at the very beginning. Okay, so if you look at tables of their values, you will see that their points are flip-flopped from each other. Okay, so I can tell if my functions are inverses by looking at a table of their points. Okay, so if they're flip-flopped from each other, they are inverses. All right, a second way I can tell that my functions are inverses by looking at the graph. So if you sketch in this x equals y line and you can flip one graph and it lands on the other one, then you have inverses. Okay, then the third way to tell if your equations are inverses is algebraically by doing the composition of those two functions. So if you check the